Good morning, Math 8. Welcome. I'm glad that you're here. All right, today we're going to talk about solving systems of equations through substitution. So go ahead, do your warm-up, substitute the values in for each variable, and simplify. Go ahead and pause the video. All right, so here are the solutions. I took those variables, I substituted them in where they needed to go, and then I simplified as best as I could. Oh, it looks like I forgot some highlights. We'll throw those in. That was blue. And that's where I got the pink from. All right, let's go ahead and move on. So our goal today is that I can solve systems of equations using substitution. There are 3 different ways that we can solve systems of equations. Last time we talked about how to solve using graphing, and today we're going to talk about solving using substitution. The other way is called elimination, and you'll do that when you hit Algebra 1. Our learner right responsibility for today is to express thoughts about possible solutions. So what does it mean to substitute? Go ahead, take a moment, pause the video, think about it, and write your thoughts down. What does it mean to substitute? All right, so substitute means to put in the place of another. So if you have a substitute teacher, you have a teacher that is replacing your regular teacher. Granted, those ones are temporary, but it still means the same thing. So in our example earlier, right, the 3 stood in the place for the x. The -7 stood in the place for the y. And the 5a plus 2 stood in the place for the z. We substituted those values for those variables. So if we're going to use substitution to find the solution, the first thing we need to make sure is that we have something that equals something else. So as we can see in this problem here, we have that y equals -3x plus 5. And since I know what y is -3x plus 5. Everywhere that I have a y in the other equation, I'm going to replace with -3x plus 5. So what that's going to look like is I'm going to still keep this 5x minus 4. Nothing happened there. But instead of y, I'm going to do parenthesis, -3x plus 5, close my parenthesis, equals -3. Ooh, that's ugly. Equals -3. There we go. So I kept that bottom equation, and the only thing that I changed was that y, because we know that y is -3x plus 5. So now I'm just going to do my math how I normally would. I see I've got parentheses, so I need to distribute this -4 into everything inside the parentheses. Nothing over here happened to this 5x, so that's just going to get rewritten. -4 times -3x is a positive 12x, and -4 plus 5 is -20, equals -3. All right, from here I'm going to combine my like terms, which is 5x and 12x, and 5x plus 12x gives me 17x. Minus 20 equals -3. Now, from here, we can do our circle of don't touch if you still need that, which is my -17x. What's outside that circle that's got to go is that -20. In order to get rid of that negative, I need to do the inverse operation and add 20 to both sides of my equal sign. And I'm left with 17x. That turns to a 0, equals 17. From here, my last and final step is to divide, right? 17x, 17 times x. The only way to split those up is to divide. So I'm going to divide both sides by 17, and I end up with x equals 1. I'm going to put my nice fluffy cloud around it. I'm not done yet, but that's important information that I need for later. Now, the reason that I'm not done is because I solved for x, but I still need to know the actual value of y. Remember that we talked about solutions of systems are the point where two lines cross each other. And I can't say that this line crosses at 1, negative 3x plus 5. That's just silly. So we need to now substitute this value of x back into one of these two equations and solve for y. So I'm going to plug it into this top one up here because it's already y equals. So I'm going to say y equals negative 3x plus 5, but instead of the x, I'm going to replace it with the 1 that we found earlier. So y equals negative 3 times 1 plus 5, which gives me y equals negative 3 plus 5, which gives me 2. I'm going to put my little cloud around it. Now, I chose to use the first equation because it was already set up nicely. But we can use the second one if we want, and I'll show you. All right, so I'm going to write on top, don't have to do, because you don't have to do this. So when you look back, I want you to remember, you only need to choose one. But we can say 5x minus 4y equals negative 3. And again, we're going to substitute that x in for 1. Sorry, I said that backwards. We're going to substitute 1 in for x. So we're going to say 5 times 1 minus 4y equals negative 3. This becomes 5 minus 4y equals negative 3. This is my circle of don't touch, so I'm going to subtract 5 from both sides, and I end up with negative 4y equals negative 8. Divide both sides of this equation by negative 4, and I get that y equals 2, which is exactly what we got earlier. But look at how much more work that was. You can absolutely do it, and it is great practice for multi-step equations. Absolutely. But it is definitely a lot more work, so there's more room for error. But all right, now we know that x is 1 and y is 2, so all that's left now is to actually write down our ordered pair for our solution. And I'm going to write down the word solution as well, just because it makes it a little bit easier to see. And I'm going to say 1, 2, because remember, it's always x, y. And that's it. That is our solution. All right, if you need to catch up on any part, go ahead, pause the video, rewind the video. That's the glory of these videos. Otherwise, we're going to move on. All right, so now I want you to give this one a try. All right, use substitution to find the solution. Go ahead, pause your video, and give it a try. All right, and here is the solution. So our solution here is 2, 3. Go ahead, take a moment, pause your video if you need to, but check your answer. If you got something wrong, make sure that you fix it and you can see where you made your mistake. If you're not quite sure, double check with your teacher. Maybe go back and watch the previous example so that you can see. All right, let's move on to the challenge problem. Go ahead, use substitution to find the solution and pause your video. All right, so this time we can see that we ended up having 6x minus 6x, which gave me 0x. So I have no x's in this problem at all. They completely poofed. They vanished. They're gone. So I end up being left with negative 15 equals negative 9, and that's not true. If you owe me $15, that is not the same as saying you owe me $9, right? They're not the same. So when this happens, when we get two numbers equaling each other, but those numbers are different, we have no solution. And if you remember back when we were graphing, no solution meant that we had two parallel lines. And that's really what's happening here. These two lines are both parallel. Give me a moment, I'm going to pause real quick, and I'm going to show you that this top equation is very similar to this bottom equation. So as you can see, when I take this top equation and I put it into slope-intercept form, we end up having the same exact slope for both equations. And when that happens, that means that our lines are going to be parallel. So there's going to be no solution. So if we were to graph this, we would get two parallel lines. But when we solve using substitution, when we get two numbers that equal but aren't actually the same number, we get a false statement, we get no solution. So now I want you to take a moment and think about how would you know if the solution was infinitely many solutions, right? Like we just said, we had negative 15 equals negative 9, which is not true, so we got no solution. What do you think it would need to look like in order for the answer to be infinitely many solutions? Once you've answered that question, you are done. So have a lovely day, and I'll see you later. Love you, bye.